students, hope you are well by the grace of Almighty Allah. Welcome to NIBS Home School. This is Mohammed Emdadul, Assistant Teacher of Mathematics, National Ideal English School, Basic. Dear students, today I am going to conduct a higher mathematics class of class 9. Our today's topic is Chapter 2, Partial Fraction, Part 2. In this part, I will show you a rule for expressing a fraction as sum of partial fractions. How can we express a fraction as sum of partial fractions? Okay, dear students. Now, at first see our today's question. Express as partial fraction. So here is a fraction given. We have to express this fraction as partial fraction. Okay, dear students. In the last class, I have told that there are different ways for expressing a fraction as partial fraction. In the last class, I have shown you two different ways: when the fraction is a proper fraction and when the fraction is an improper fraction. In the both case, the denominator have the factors where there is no quadratic factors and repeated factors. If there is no quadratic factor and repeated factors, then the problems how to solve I have shown you in the last class. In today's class, I will show you if there is quadratic factor in the denominator, then how can we express the fractions as partial fraction. Okay, dear students. So let us see our today's question. Here the given fraction is x square minus 4x minus 7 divided by x plus 1 and x square plus 4x. Here this factor x square plus 4 is a quadratic factor, is a quadratic expression. So this factor is a quadratic factor. If there is quadratic factor, then we have to apply another technique to express this as partial fraction. Okay, dear students. So I will show you that in our today's class solution. Dear students, so at first I will write here let x square minus 4x minus 7, that we can write in this way: x plus 1 into x square plus 4 identical to, here we can write a divided by x plus 1. When we will write general expression that is not quadratic, that is not repeated factor, in this case just I will write a constant in the numerator and we will write a simple factor in the denominator. Then next part, here this factor is quadratic factor. In case of quadratic factor, when you will write the quadratic factor in the denominator, then you have to write the numerator using the technique. Here is a constant with a variable and then another constant. It means we have to express in this way. Suppose bx plus c. Suppose bx plus c, if the denominator is a quadratic factor or quadratic expression. Okay, dear students. So we can consider this is equation 1. This is equation 1. So now we can multiply both sides of 1 by the denominator of left side. So we can write here multiplying both sides of 1 by x plus 1 into x square plus 4. We get, what will we get? We will get here, if we multiply by this 2 vanishes, only x square minus 4x minus 7 will remain in the left side, and when we will multiply in the right side at first the first fraction, then this x plus 1 will vanish. So with a we will get x square plus 4, and when we will multiply the next fraction, then we will get here bx plus c. We have to multiply by this x plus 4 will vanish, so x plus 1 will remain here. So we can write here, this is our obtaining equation or identity. Okay, dear students. So we can write here, or we can calculate here x square minus 4x minus 7, that is identical to a into x square means ax square plus 4 into a means 4a plus, if we multiply, this will be b x square plus this will be bx if we multiply this 1 by bx, and here is c into x means cx, c into 1 means c. So we have multiplied now. Now we can add the similar terms. We can write, left side will remain same. So we can write here ax square bx square. So we can write a plus b into x square. Then here is bx cx. So we can write here b plus c into x. We can take x common plus, here is 4a, here is c. So we can write 4a plus c. Now see this term, this is the term x is containing x square, this is the term containing x, and this is constant term. Okay dear students, now here a, b, c are constant. So we need to determine the value of these constants. Now how can we determine the value? To determine the value, we need to equate the coefficient of the term x square, x and constant term. So we can write on both sides of 2, equating the coefficients of, on both sides of, this is equation 2, on both sides of 2, equating the coefficients of x square, x and the constant term. Constant term we get. Dear students, now see, in the left side this is a polynomial, in the right side also this is a polynomial. In the first class of this chapter, I have discussed that two polynomials are said to be equal if the coefficient of the similar terms are equal. So we can write here coefficient of x square is 1, here coefficient of x square is a plus b. So we can write here a plus b equal to 1. From these two we can write here a plus b equal to 1. Now see the next term, x, coefficient of x is minus 4, here coefficient of x is b plus c. So we can write here b plus c is equal to minus 4. Now this is constant term, this is constant term. So we can write here 4a plus c, 4a plus c, this is equal to minus 7. So from these three equations we need to determine the value of a, b and c. Solving these three equations, give this is equation 3, this is equation 4, this is equation 5. Now if we subtract 4 from 3, we will get the value of a and c, it means we will get a minus c. Subtracting 4 from 3, we get, what will we get? So this b and b vanishes each other, it means a minus c, we will get a minus c, that is equal to, this will be negative, this is negative, this will be positive. So when we subtract, so we can write 1 plus 4 means 5, 1 plus 4 means 5. Suppose this is equation 6. Suppose this is equation 6. Now if we add equation 5 and 6, this c and c will vanish and we will get 4a and a, it means 5a. So we can write here adding equation, adding 5 and 6, we get, what will we get? We will get here 4a and a, sum will be 5a. That is equal to 5 is positive, 7 is negative. If we add, we will get here minus 2. We will get here minus 2. So now, to determine the value of a, we have to divide minus 2 by 5. We will get here minus 2 by 5. So this is the value of a. Now, if we put the value of a in equation 1, we will get the value of b. So putting the value of a in 1, we get, what will we get? Here value of a we have to put here, that is 2 by minus 2 by 5 plus b, that is equal to 1, that is equal to 1. So we can calculate here, we will get here b equal to 1 plus 2 by 5. That will be equal to, when we will change the side, this will be positive. So that will be equal to, if we calculate 5 ones are 5 and 2, that is 7 by 5. You can calculate here. Okay, now I have determined the value of b. If we put the value of b in equation 4, sorry, this one is not equation 1, this is equation 3. Now, if we put the value of b in equation 4, we will get here value of c. So we can write here, putting the value of b in 4, we get, what we will get? We will get here value of b is 7 by 5, 7 by 5 plus c, that is equal to minus 4, minus 4. So we can write here, that is c equal to minus 4 minus 7 by 5. It means, that is, if we write here, now if we calculate, we will get here 5 in the denominator and minus 4 here is, so 5 4 are 20, minus 20 and minus 7, that is minus 27, minus 27. Okay dear students, so we have determined the value of a, value of b and value of c. Now if we put the value of a, b and c in 1, we will get the required partial fraction. So we can write here, putting the value of a, b and c in 1, we get, what will we get? Now see, left hand side, x square minus 4x minus 7, that is equal to, that is by x plus 1 into x square plus 4, that is equal to, we can write here, value of a is minus 2 by 5, minus 2 by 5. I have determined value of a, that is minus 2 by 5. So we can put the value of a here. So we will get here, that is x plus 1, then plus, what will we get? Value of b is 7 by 5, 7 by 5 into x plus value of c, here is minus 27 by 5. So we can write product of plus and minus will be minus 27 by 5, 27 by 5. So we can write here, that is x square plus 4. Now we can calculate little bit here. If we calculate here, what will we get? We can take 1 by 5 as common, 1 by 5 as common. If we take 1 by 5 as common, we will get here. I want to take the, as this is negative, so I want to write this one in the as the second fraction and this one as the first fraction. So I am writing this one at first. So if we take minus 1 by 5 as common, here will be 7x in the numerator minus 27 and divided by x square plus 4. As this is negative, I am writing later this one. So here will be 2, here will be x plus 1, 2 by x plus 1. So this is our required partial fraction. So we can write here which is the required partial fraction. Which is the required partial fraction. Dear students, I hope you have understood the process when you will get a quadratic function, when you will get a quadratic factor in the denominator, how to express a fraction as partial fraction. I hope you have understood our today's lecture. Keep practicing at home, abide by your parents, stay home, stay safe, see you again. Till then, Assalamu alaikum.